mess something up. She looks confused. Okay. All right, we all okay with this so far? Next, we're going to have to do all of these O minus E squareds divided by E's and a summation of all of them. So Nathan wants to do this, and we might as well just give it a shot. So let's try it. We're all going to try to do this on our calculator and have it do it for us. All right. So you are going to go to Data, Stat Edit, and make your L1 list look like the observed and your L2 list look like the expected. All right, so far we're here. Let me know when we're all in the same spot. Everybody good to go? Justin, you good? Yeah. Okay. All right, what do we need to do now?
Stat, calc, tests.
Sure. If we were going to do it that way, we would totally do the GOF test, which we're going to do in just a minute. But for right now, I want to do this like the longhand way, but the Nathan way where he makes it do it for him. So how do we make, what should our next column be?
The whole equation.
Sure, you can absolutely put the whole equation in. So we're going to put in, you see where it says L3 at the bottom now? So I'm going to write parentheses. And then I'm going to write second L1 minus second L2, parenthesis, and then I'm going to square it, and then divide by what? L2, which is that expected column. And if you hit enter, it does all of them. Which is a nice way to show your work on the AP test. If they ask you to like show what you're doing, then you can say, okay, I'm taking all of the observed minus the expected squares divided by expected, and here are those numbers, and you write them down. But it says we also need a summation of that, right? So how do we do a summation of that list? One variable stats? You got your classic, one variable stats, but what list are we wanting it to sum up? L3. Which is this one right here, that's 16.96. So I'm going to write chi-squared equaled 16.96 when I did the test, which falls over here. Which means what?
Reject the null and accept the alternative.
I'm accepting the alternative, and the alternative is that these do not match each other. So basically I'm saying, look, it's not close enough, it's not good enough. They're too apart. If I was going to write a sentence on this, I would say, there's enough evidence at the 1% significance level to reject that the observed frequencies match the expected frequencies of tax preparation. All right, we're going to try example 3 together, only this time we're going to do that goodness of fit test in your calculator. And of course, I didn't actually put the stuff on there, which I should have. Okay. So, a researcher claims that the number of different colored candies in the bags of dark chocolate M&Ms is uniformly distributed. What does that mean? All equal. There's the same number of oranges and greens and stuff like that as there would be. But here's what the actual results were. So N is equal to 500, because they did 500. And there are 6 different colors. There's brown, yellow, red, blue, orange, and green. All right, so first we're going to write down the observed and then what we expected to have happen. So according to this researcher, it looks like they got 80 brown, 95 yellow, 88 red, 83 blue, 76 orange, and 78 green. But what did we expect to have happen? How do we find that out?
Do your n divided by k.
N divided by k. In this case, what, 83-ish? It doesn't add up exactly, but 83.3. We were expecting this for each. Obviously, we weren't expecting the 0.3, although sometimes you end up with broken M&Ms in the bag. Looks like just nailed it exactly on for blue. So what do you think, guys? Is this going to be close enough? I'm going to guess yes. And I don't remember what the answer is, in case you're wondering if I'm cheating. And here's why. Here's why I think that it's close enough. See, the alpha is 10%. We're willing, that's a pretty high. We're willing to be 10% incorrect, which means that we're willing to make some errors. The last test we did where it didn't get close enough was 1% off, right? So that's pretty exact. Okay, this time we're going to do a test. So go to Stat, Edit. Actually, I don't remember how to do this, so give me a second. I know it's goodness of fit test. Yeah, they have the observed and expected. Okay, clear. Or did they do it themselves? There's one of these tests where it calculates it itself, and I don't want us to mess it up. Well, let's try it. Let's go to Edit. Clear out your lists. And then put in the observed frequencies. I don't even know if it's going to let us do 83.3, but let's try. It might give us an error and say like it has to be a whole number. What was that? Oh, did you already try? Did it work? Okay, so I'm going to go to Stat, Tests. I'm picking the one that says chi-squared GOF. Observed was L1, expected was L2, degree of freedom is 5, that's correct. And then we're going to draw it. It did work. The chi-squared value is 3.01. P-value is 69%. Okay, just by looking at this picture, can you tell me right now, accept or reject? The null. Mm-mm. Except, see how it's landing